Over these two problems for the law of sines and cosines worksheet because I think these are probably the two hardest ones. So let's go over these cases. So when you are given side angle, so I know this isn't side angle side because I'm not given the angle between these two sides. I'm given an angle, I'm given the side across from it, and then I'm given an adjacent side. So this is side angle. I recommend that you always draw your pictures the way that I draw them, which is have your given angle here and create a horizontal line. Okay, so that's like the base of the triangle. I've got my given angle, I've got my side length across from it, and then my side length adjacent goes here. The reason I want to do that is because remember, with the ambiguous case of law of sines, you need to solve for the height first. So if you set it up with a horizontal base, it's easier to see what the height is. So to solve for the height, that's going to be SOHCAHTOA. So sine of 80 is equal to h over 22. So my h is 22 sine of 80. So I plug that into my calculator, 22 sine of 80, and I end up with 21.666. And okay, so let's think about this. So I have a height of 21. I've got a length here of 22. So that's 21, okay? Can I have a length of 6 be the opposite side? Is there anywhere for me to like pivot that 6? So just think logically. 6 is pretty short, right? I am pivoting this side length across. I can never reach the other side of the triangle. Remember, your side across from the angle has to reach the base in order to complete the triangle. There's no way for 6 to reach all the way the other side if the height is 21. So this is no triangles. Because there, with the height as large as it is, there's just no way for that 6 to reach the opposite side. So again, it's with the quote unquote ambiguous case of law of sines, because the height is greater than the length across from the given angle, that means there's going to be no triangles. Okay, with this next one, C. So again, I recommend that you draw your triangle so that the angle is here. The side across from it is here. The adjacent side is here. And then this is your unknown base. Okay, we got to solve for the height first, and that will give us an idea of how many triangles there are. So 23 sine, you can use SOHCAHTOA again if you need to, but it's going to be 23 sine of 48 is equal to the height. So the height is equal to 23 sine of 48, 17.092. Okay, well, 21 is greater than the height, so I know it creates at least one triangle because it is larger than the height. And it's also less than 23. So because your side length that's across from the given angle is in between the adjacent side and the height, this is going to be two triangles. So let me draw the two triangles. So one of the triangles is the one that I have here, where I have like this acute triangle. The other one, I can swivel the 21. So I still have 48. I still have 23. But I could swivel that 21 over, so it's here, and creates a smaller obtuse triangle. Okay, so I just want to point out that this is C, this is B, and this is A. This is going to be ambiguous case again because the height is less than this side length, and this side length is less than the adjacent side length. So if the side length across from the given angle is in between the height and the adjacent side, you're going to have two different triangles because you're essentially taking this side, again, think about like swiveling this side length over. I can swivel it over so it's here, and then I end up with like this smaller obtuse triangle. All right, so this is two different triangles. So let's solve for, I'll call this one a sub 1 and b sub 1. And this will be a sub 1. Okay, so let's solve for b sub 1 first. So b sine of b sub 1 over 23 is equal to sine of c, which is 48 degrees, over 21. Multiply both sides by 23. Do sine inverse. I plug that into my calculator. Sine inverse of sine of 48 times 23 divided by 21. 54.481 degrees. Okay. I'm not going to finish this problem for you because I believe in you. You can do this yourself. C sub 1 is going to be 180 minus B sub 1 minus A, or I'm sorry, minus C. Sorry, I had that wrong. A sub 1 is equal to 180 minus B minus 48. And then to solve for side A, it's going to be sine of whatever this ends up being over A sub 1 is equal to sine of, and keep using the 48 over the 21. Okay, and then you cross multiply and you can solve. So the rest of this you can do. But what about B sub 2? Okay, so B sub 2 is supplementary to B sub 1. So it's going to be 180 minus 54.81 degrees, which is 125.519 degrees. So that's going to be your second angle B. And then your second angle A is going to be, again, 180 minus B sub 2 minus 48. That'll solve for A. And then again, you're going to do sine of whatever that is. Keep it plugged into your calculator so you have an exact answer, is equal to sine of 48 over 21. And then cross multiply and solve. But the important thing here is understanding when you have the ambiguous case of law of sines with two triangles. And again, it's when the side opposite the given angle is a number in between the height and the adjacent side. If it's greater than the adjacent side, then that's just going to be one possible triangle. If it's less than the height, like in number 5, then there are no triangles. And if it's equal to the height, then that means you have a right triangle. So there's only one possible triangle.